Thank you for having me. Thank you for the organizers. And thank you for the creators of Native Histograms, because they are great. And in this talk, I will talk about why they are great and why you should also probably use them. My name is Krisztian Fekete. I'm working as an engineer at Solo.io. That company is building products on to solve the application networking challenges. We are one of the biggest contributors to Istio. Who is using Istio, by the way? Not a lot of people, but there's some. If someone wants to chat about Istio, then feel free to find me after the session. And you can see my contact information here if you have any follow-up questions afterward. Some interesting info. This is my third time presenting during an emergency warning system test this year. So not sure what's happening this year, but I think the first one was KubeCon, the previous one was in NDC Oslo, and yeah, this is the third one. I'm excited. And I'm using Prometheus since around version 1.6. That was a while ago. So first, let's take a look at what the classic original histograms were and what was the problem with them. I will try to do these first couple of slides pretty fast, because there was yesterday already a talk on this topic from Pedro and his colleague. And you can also find lots of talks from Björn and Julius, and there are other great presentations on this topic as well. The documentation is also quite nice, so feel free to check those out if you have further questions on the design and implementation. So this is the original definition from Prometheus.io, I think. Histogram is basically collects the samples and observations into buckets, and you can visualize these different ways. And you have lots of helper metrics that you can use to get the rate, get the sum, these kind of things. One important implementation detail is the fact that it has configurable buckets. The bad thing about them is that you need to configure them yourself. This is a standard example of a classic histogram. You can see that the buckets are basically under the LE label. This is the distribution that you need to come up with during development. You can see that how these numbers are growing, and that's not because the application is getting smaller and smaller. That's not how Prometheus works, but that's because this is a cumulative histogram. That means that, not sure what is the best, maybe this one. So for example, if you take a look at the bucket number 10, then you will see that that's the largest, and that's because that includes all the observations from the smaller buckets. That had some benefits with the classic histograms, mainly due to operational and cardinality issues. So that's one of the problems that native histograms will solve. So the two main problems are inflexibility. You have to choose your bucket layout beforehand. Mostly that's a time when you have no idea what kind of buckets would make sense for your applications. I mean, you can develop a standard web application where you can have some idea about what a good distribution would look like, but you can be also doing, I don't know, embedded development or kernel development or some other exotic use case where you have basically no idea what would make sense later in real life. And these buckets are also expensive. You have separate time series for each and every one of your buckets. If you are talking about the text exposition format, you will have a separate line for all the buckets. So this can get expensive. That was it. That's the old classic histogram. Now let's take a look at how native histograms are better. They are more flexible. You have an automatic logarithmic bucket layout that will try to take the shape of your traffic, if it's traffic, or just the shape of observations coming into your application. So that's already nice. And it's cheaper. You can get higher resolution for less. Basically, I think it's about 10x resolution for half the this original size. I'm not exactly sure about that, but you can look it up. You can save some cost that way. This is what it looks like in a fairly recent Prometheus. It's not the latest one, but it might be the latest visualization. Yesterday there was a talk about creating this. That was a talk that I really enjoyed. You should look it up if you missed it. And from the shape, you can already tell that this is an uncumulative histogram. In a certain bucket, you only have the observations that are tied to that actual bucket. It's cheaper. The zeros are not tracked. So if you were to have some zeros somewhere, those are not stored. So you can save some cost that way as well. Although if you have a small number of observations falling into these buckets, it can get expensive again. But to solve that, you can basically just reset. Everything is a counter. You can reset counters. That's how they work. And you can also do this. You should do this periodically if you are doing the actual native histogram instrumentation. If you are using Go, most probably you are using Go if you are playing with native histograms, or Java, but I think you are using Go if you are playing with this at the moment. Then you can use this native histogram min reset duration option. This is how you would instrument a classic histogram in Golang. This is actually from our code base. We are tracking translation times. I will talk a very, very small amount of time about what kind of translation we are doing in our product. It's not that exciting or interesting, but it will help you to understand what's happening in our stack. But basically, you have translations, and the greatest way to visualize and measure translations is doing it with histograms. So you can see that you have to name it. You choose your namespace. You can write a help text to help your developers and operators to understand what that metric actually is supposed to do. Actually, you should use a better name than this one. But if you are maintaining metrics in systems that are used by many people around the world in lots of different environments over many years, then you know that how hard it is to rename metrics and be compatible with the new naming and the old naming. So this is why the naming of this metric is not perfect, unfortunately. The important thing about this is that you have to choose your buckets. Here you can see that the smallest is 0.25 seconds, and the largest is 60 seconds. This actually can be fine if you are a developer doing local developments on your laptop, you are running a kind cluster or a K3D cluster or a V cluster or any kind of small local Kubernetes distributions. It can be even fine if you are running in a small environment, only a couple of applications. It should just work. It should be fairly good. But it's not fine if you are a huge bank with, I don't know, hundreds of clusters, hundreds of thousands of resources across multiple clusters, multiple cloud providers, or if you are any other big company with lots of workloads in your cluster. So to fix it, you can just implement native histograms by adding these 3 extra lines. You can specify the histogram bucket factor, which is the maximum size a certain bucket should grow from the previous compared to the previous one. You can specify the maximum bucket number and the reset duration that I already mentioned. That's the only thing that you need to do. Afterwards, the code itself should be fine. All the other plumbing that you need to do is more like on the ops side. You have to configure it in Prometheus. You have to do other things if you are using other, for example, OpenTelemetry collectors. I will talk about those in a bit. So why native histograms are a game changer for Solo.io, and probably also for you. You might just haven't had the time to play with them. As I mentioned already at least 2 times, it's hard to know. Sometimes it's impossible to know what kind of bucket distribution would make sense for you. Or if you know what would make sense for you, that might not be what would make sense for your end users running a completely different setup in their infrastructure. what you could do traditionally is you could iterate and do code changes, build another version of the project, and try to find a better bucket layout. But you would have backward compatibility issues. It's very hard to deprecate a previous metric and change the inner behavior of a certain metric because people might have alerts or dashboards for those metrics. And it can be also different across many users, as I mentioned. Another workaround that you could do, some projects are providing a way to work this around, is to expose a way for the users to change this without recompiling the code. If your code is not open source, obviously your users cannot configure this. But let's say if you provide a way to specify the buckets during runtime, then that's a bit better because at least there's a possibility to change them. Although the UX is not great, and the users will probably still need to iterate a couple of times until they get it right. They get tired of trying to get it right, and they probably, or there can be cases when they just wouldn't care anymore and they are running with the wrong layout. For example, Istio itself is providing a way to do this. You can use an annotation to specify a custom layout that can be specific to an application. You can use a specific distribution between your proxies in specific applications, or use another one for your ingress gateway, for example. That's the way that project solved it. But it would be nice to also provide a proper native histogram support in Istio itself. The instrumentation, I think all in Istio project is using OpenTelemetry instrumentation, so exponential histograms would be the way to go about this. Promising areas where this can be important is, I think, everywhere, most of the time, everywhere. You should basically play with it and see if it works for you or not. Especially in infrastructure-related software. In infrastructure-related software, it's hard to know how certain latencies will look like, depending on lots of factors. And there are also interesting use cases, bleeding edge and experimental use cases, such as edge computing or eBPF. We also have an open source project. It's called Bumblebee. Not sure if someone has maybe already used it. You should look it up. It's a cool open source project that is basically lets you take an existing eBPF snippet from the internet, from the BCC repository, package that as an OCI image so that you can push that into OCI repositories. You can do something like b push and b run, and then you can run your eBPF code without writing a single line of user space code. And the really nice thing about that, and the reason why I mentioned, is that it will automatically create Prometheus metrics for you, which is very nice. You can get some kernel-level insights without writing user space code by pulling an image that is basically almost like a Docker image. And in eBPF, if you want to visualize latency from the kernel, then that's a very good area where this native histogram can be beneficial, because it's quite troublesome to even try to come up with a bucket resolution or provide a way for the users so that they can override this. You need to create another map where you are storing your bucket layouts. Anyway, it's not an easy job. But with native histograms, you can basically just forget about this and get really high resolution data from the kernel itself, which is really great for troubleshooting. You should look it up. If you have any questions, feel free to catch me after the talk to show you this in action. And there can be other areas as well. I hope your use case will also benefit from native histograms. Finally, let me talk a bit about our phased migration strategy in our products. Just let me drink some water beforehand. It's important to stay hydrated. This is a simplified, high-level overview of our solution. As I mentioned, we are in the application networking business. Our Gloo Mesh Enterprise project is focusing on multi-cluster service mesh management based on Istio. The way it works in very short, is that you have a management cluster. The management cluster that is up there. You can also host workloads in the management cluster, but obviously there can be some cases, for example, production environments, where you would prefer to have a dedicated cluster for the management plane. So that's what you have up there. And then you have the workload clusters. That's where your actual workloads are running. That's where your business applications are running. In this cluster, you have an agent. In the management cluster, you have a management server. And what is happening behind the scenes is that we provide a high-level API on top of Istio primitives, just to oversimplify it. And when you apply our policies, and our policies are more enterprise-ready, provide multi-cluster capabilities natively, the management server will turn these into actual Istio primitives behind the scenes. So that's what I mean by a translation loop that happens lots of times, multiple times per minute or seconds in our product. You can see that in the workload cluster, we have a OpenTelemetry component. That's an OpenTelemetry collector, our special distribution, that is collecting logs, traces, metrics from the workloads. Then these are pushing this telemetry data to another OpenTelemetry collector, which is deployed as a gateway in the management cluster. And this is needed because our management cluster and management plane is basically providing a way to visualize a service graph based on metrics. You can have a service graph without tracing, without adding a single line of code, just via the metrics that the collectors are collecting. And we are pushing all of these into the management cluster so the collector can make this data available. There we have a pretty lightweight Prometheus instance. That Prometheus instance is sending PromQL queries to the UI, and the UI is visualizing the service graph. That's basically, in a high level, what our project is doing. The way to try it out in the first phase, because of some blockers are available, and because it's still experimental, is that what I recommend to our biggest customers who are interested in getting an actual look at their actual translation times and reconciliation times is to drop another Prometheus right next to the management plane. That should be, for example, in the management plane. That can be even Prometheus 3.0. You should try it out with Prometheus 3.0. That Prometheus has native histograms enabled, so you have this special flag, or maybe you don't even need the flag after 3.0, I'm not sure. But if you are using an older version, you should definitely use the flag. Then you can use that Prometheus instance to scrape our control plane components to get this data. The reason why I recommend our users to try it out this way is that, as I mentioned, there are some blockers. I will talk about these. Yeah, here they come. In our pipeline, by default, we are not pushing metrics once they are in the management cluster. We are just making them available for our Prometheus to scrape. That means that we are using Prometheus exporter, which is exposing the metrics in Prometheus format. But Prometheus exporter cannot expose them because the text-based format for native histograms is still not available. So these are the GitHub issues that I'm waiting for before we can support this natively. We will probably have a Helm flag that can enable another variant of the pipeline in our open telemetry collectors so that the users have a very nice experience migrating from one of the histograms to the other histograms. But for the time being, I think in phase one, this is also a good approach. It only covers our control plane, which is not as business critical as the actual workloads. Obviously, it's infrastructure, so it's important to keep a track of everything. And you should also have SLOs for your infrastructure-related software. But it's still, I think we can say that it's less critical than the actual applications in the data path. So that means that we don't have to care about backward compatibility that much. If you are just using a Prometheus that you are dropping into the management cluster, and the UI is not using that, you are only using that dedicated Prometheus to get that diagnostics data, and you can hook that Prometheus into the Grafana that you are using that has your other Prometheus so that you can compare the two side by side. So it's a safe, opt-in way to try it out, get some idea about the actual translation times and all the other histograms that we have. I added native histograms to all of our histograms, basically. If it's opt-in and if it's tried out in an opt-in way like this, then you cannot really break anything with that. Our recommendation and the approach that we are taking with our dashboards that we are providing for our projects is to use the OR operator in the panels. That means that you can have your query for the new histogram syntax and metric names, and you can use OR. So when you don't have these, you will just fall back to the classic histograms. So the users don't necessarily need to keep another version of the dashboards up to date if they want to compare things. This is our operations dashboard that is showing histogram on multiple panels. Unfortunately, I just realized that I forgot to include another version that is using the new histogram. That would be nice. But you can see the heat map with the classic histograms, and it's how it looks like. This is another dashboard that I created during trying all this out. On the left, you can see classic histograms. On the right, you can see native histograms. You can see the increased resolution that you can have. And you can also see that how on the left side you have straight lines, while on the other end of the dashboard on the right side, you have these spikes and you have more insights into what's actually happening in your applications. And this is my favorite. You can finally visualize the 100th percentile. On the left, you can see that if you have a bad bucket layout, then when your application is not performing great, then you can have most of your observations falling into the highest bucket, so that you have, in this case, 60 seconds is the largest one, so everything will be capped at 60 seconds. While on the right-hand side, you can see that you can actually get some insight into what the actual performance of your applications is. And yeah, I think this screenshot is the best example of why you should try out at least native histograms and play with them, because these can provide information that you might have never seen before. The queries are also changing. The PromQL syntax is also changing. This is a fairly generic example, and I also missed a couple of new functions that are available, like histogram fraction, for example. You should also look those up to utilize the native histograms the best you can. So that was it. I hope I made native histograms interesting for you and get you to try them. I'm here for Q&A, and I'm also available after the conference, so you can find me and chat about all these things.
All right, do we have questions?
Not a single one. Everyone is busy with their laptops trying native histograms out. Or maybe not. Maybe it's just too early in the morning.
That's actually a good segue. Has anyone deployed Prometheus 3? Maybe even yesterday or today? Anyone fiddled around? Basti in the back doing the live stream. Seems like you don't have enough to do with the live stream, so you're like deploying Prometheus 3 on the side. That's great. So I guess, yeah, go ahead, and maybe you have some time tomorrow to try it out. But yeah?
Still no
questions?
That's fine. I'm not offended.
Thank you for your talk.
Yeah, thanks.